Good evening, everyone. Welcome to the stream. We have just about 5 minutes to go until tonight's Advent of Code puzzles unlock. Welcome, everybody. As always, we are going to be working through the solutions to these puzzles in C++. Glad to have everybody join in the stream. As always, you can feel free to ask me any questions that you have in the chat. And if you miss a stream, you can always view the replays on YouTube. That's at my YouTube channel at youtube.com/spoonboy42. If you're watching the live stream on Twitch, there's a link in my profile. Conversely, if you are watching this replay later on YouTube, you can always see the live streams on my Twitch profile, and the code for everything that we solve here will go up in my GitHub repository. There's going to be a link to that down in the description as well. It's github.com/craig-chasseur/AOC2020. And you can see that on the screen right now. So last night, we solved the puzzle relatively quickly. We used a little bit of a dynamic programming solution for part 2. I was pretty happy with this, where, we figured out how many different suffixes of a solution existed, assuming that you got to one particular adapter in our gigantic chain of electrical adapters, and just worked backwards through there. So this is kind of a sign that we're getting into maybe a little more of the algorithmically tricky puzzles in Advent of Code. Which is exciting. These puzzles are fun to solve. But, it also means that, it might take a little while longer. It might take a little more thinking on my part. And, one of these nights I may have to step away without a complete solution and think about it a little more or get some hints. So bear with me. We'll do the best we can on these. So, right now, we have a little under 3 minutes until the puzzle unlocks. So I'm going to go ahead and just set up our basic scaffolding, like we do every night, for our day 11 solutions. So we'll do part1.cc. We are going to have our bare minimum main function here. We are going to set up our build file for the Bazel build system that I'm using to actually be able to build that. And let's go ahead and verify that that does indeed build. And we'll go ahead and run it too. Okay, we are ready to go for the first part of our day 11 solution. So we've got about a minute and a half until the puzzle unlocks. We can see more of the picture filling in here. It definitely looks like a flight path for the trip that we're taking. What's kind of interesting, though, is that there are gaps in here where the sequence kind of jumps around. I wonder if eventually we'll be headed back north, or we'll be making a round trip, and we'll fill in other lines between the gaps in the little picture that's forming on our calendar here. I don't know. We shall see. So yeah, last night was our personal best so far for this year on part 2. We cracked the top 1,000 for the first time, which is pretty nice. I think, there's still a lot of people solving these, but one thing that I think is kind of interesting is that, at least for last night's puzzle, there's a pretty decent number of people who got the first part but who haven't gotten the second part yet. And I think that is maybe down to the fact that we're now starting to see things where you can't just brute force it on the second part, because that was one where you really needed to use dynamic programming in order to have it finish in a reasonable amount of time. Okay, we're ready to go. Puzzle just unlocked. Okay, seeing system. Land lanes with plenty of time to spare. Final leg is a ferry that goes directly to the tropical island. Okay, nobody else has arrived yet. People used to choose or abandon their seat in the waiting area. You're pretty sure you can predict the best place to sit. Okay, so we've got a map of the seat layout. So this is either floor, which is dot, an empty seat, which is L, or an occupied seat, which is pound sign. For example, initial seat layout might have these various empty seats and floor dots. Okay. You need to model the people who will be arriving. People are entirely predictable and always follow a simple set of rules. Okay. If you say so, puzzle. All decisions are based on the number of occupied seats adjacent to a given seat. Okay, so all around, including diagonals. If a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. If the seat is occupied and 4 more seats adjacent to it are also occupied, seat becomes empty. Otherwise, seat state does not change. Floor never changes. After one round, everything becomes occupied. Okay, so the process continues. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seats change. How many seats end up occupied? Okay. Let's go ahead and save our input. Let's see what that looks like. Okay, pretty big map, but we can handle it. So first thing we're going to do is check that the number of arguments to our program is 2. Oh yeah, sorry, I need to switch my screen here so you can see me coding. Check that the number of arguments to our program is 2, 1 for the program itself and 1 for the file name. We are going to use one of our input routines to read lines from the file name argument that we're given. And then we're going to write a little class called seatMap that will represent this map of seats and that can calculate its own next state. So I'm just going to keep on using the same string representation that we already have, because I mean it's good enough. Like obviously we could make this more compact. There's only 3 possible states for each seat, but you know we'll take up a byte for each one. It's fine. It's fine. So we're just going to use that same vector of strings representation. And we will have a function that counts the number of adjacent seats for a given seat. And we will, you know, specify the X and Y position of it. Although, well, we'll just say, because the vertical dimension is first in this, you know, I'm just going to be consistent. I'll just call these vertical and horizontal. So, start at 0. So we gotta, you know, make sure that for a given cell in the grid of our map, we need to make sure that we're not going outside the bounds of the map, so beyond the left, top, bottom, or right. So if vertical is greater than 0, then we can count stuff that is on the line one above. So, and then if horizontal greater than 0, so if vertical and horizontal are both greater than 0, then we can count the square that's up and to the left diagonally. So we will say an occupied seat is a hash mark, as I recall correctly. Yes, occupied. So we will say so if that equals, so if the character that's up 1 and left 1 is occupied, then we count that up. So we already know in here that vertical is greater than 0, so we're also going to add 1 for the one that is at the same, that is up 1 vertical at the same horizontal position. So it's going to be similar to this, except we are going to keep that horizontal the same. And then if horizontal is less than the width of the map, then we're going to do something similar for horizontal plus 1, so up and to the right. And then we will do the same thing for left and right on the same line, and then the same stuff for below. So we will say, so stuff on the same line. We're not going to count the cell itself, so we'll get rid of that middle one, but basically stuff on the same line is vertical is the same. And then we're going to have a very similar pattern here for stuff on the line below. So if the vertical size is less than the height of the map, then we can also count stuff on the line below, and that will be vertical plus 1 because we're counting from the top to the top down to the bottom. I just realized this method, of course, can be marked const, and so can its parameters. And so those are the 8 cells surrounding our cell, and we just return the count at the end. So now we can count up the number of occupied adjacent seats, and to get the next iteration of it, we just do so we visit every single seat in the map currently. We calculate its adjacent stuff. We should also just make a constructor here to initialize this, I realize. There we go. Make sure we include utility for move. And so to do this next, we'll just we'll initialize next with a copy of the representation that we currently have. And then for all of the cells in this map, we'll apply those rules about whether a seat becomes occupied or unoccupied. And then we'll have an inner loop that just goes through all of the cells in our seat map in the row. Okay. And now let me go back over. So if a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. So if the current rep is empty, which is the L character, and the count for the count of adjacent occupied seats for that cell is 0, then it becomes occupied. So we'll put that because these rules all have to apply simultaneously. We'll check against the current version and we'll set it in the next version. So it becomes occupied. Otherwise, if a seat is occupied and 4 or more adjacent are occupied, it becomes empty. Otherwise, seat state does not change. Okay, so if we have this as occupied, and the count of adjacent is 4 or more, then it's going to become unoccupied. And flip over to L. Okay. Are we missing something here? Else if... Oh. Well, that is why the compiler didn't like that. And then we can return next, the next version of this. And the final thing we're going to do is just implement the equals operator for seat map, just to verify that the two representations are the same. We will just use the built-in equality for vectors because that does exactly what we want to do. Okay, so got our current version of this. Now, ultimately, we need to find how many seats end up occupied when this finally converges and it doesn't change anymore. So the one more thing that we're going to need is actually just something to count up the number of occupied seats. So we'll say int occupied const total is 0. I think std count will serve us well here. I just am looking that up. Yeah. Yeah. And the value that we are looking for is the pound sign and return total. Okay. So, we'll run this loop until the next version of the seat map is the same as the current version, and then we will spit out the number of occupied seats. And of course, we will want to break the loop at that point. Otherwise, we want to move on to the next one and complete that iteration of the loop. So I think we have our solution here. Let's go ahead and add our deps to the build file. The things that we used. And instead of this container library, it's going to be just strings, because we only use string view. And let me go ahead and take the test input that they gave us in the puzzle description, and we'll use that as a little miniature check for our program, as we typically do. That out. Okay. Let's run our program on that small test input first and see what it gives us. Okay, it gives us 0, which is incorrect, obviously. So we've done something wrong, because the correct answer there should ultimately be 37. So, let's just see how many iterations it goes through. No, we won't actually count them, but we will just put that in there, and we can count on the output and see what it gives us. Okay, so I think something is wrong with our implementation of next. That should be if it's 0. Yep, forgot to put that little condition in there. Let's try it again. 37. Okay, so let's try it against our actual day 11 input. Segment. Okay, it's seg faults. Well, that's not good, folks. Did we do some out of bounds memory access somewhere? What did we do? Let's go ahead. Look at the day 11 input. That looks okay. Where did I seg fault? I'm compiling this in debug mode now, and it's still giving me a segmentation fault, but maybe if I run it under the debugger, I can find out some useful information. Okay, let's look at our backtrace. Okay, so we're in next. Oh no, it's actually in count adjacent where we had a problem. Okay, we'll go down. So maybe our bounds. I think our bounds checking has a problem. It's weird that we're not getting line tables though. But well, let me build my program now. Make sure that it has maximal debugging information so that the debugger will be super useful. I really should learn LLDB because I use LLVM everything else. I'm just still used to the GDB commands for certain things. Okay. Line 70. So, if vertical is less than rep.size, this is where we are looking on one more down at the same horizontal address. Vertical 90, horizontal 0. Okay, vertical is always going to be less than rep.size. It's got to be less than rep.size minus 1. Okay. Yeah, all these top ones were off by 1 because yeah, like it's a typical off by 1 error. But hey, I just showed how to use the debugger a little bit to figure that out. But yeah, this is classic out of bounds. So anywhere we're using the size as a limit, we to see if we can go one more. That one more still has to be less than the size, so it should just be size minus 1. So we'll just look at size. It's gonna be minus 1, minus 1, minus 1, minus 1. Okay, I think we caught them all. Thank you for your service, GDB. And now we'll run it on our actual input. Storing debug, but that's fine. 2,204 occupied seats is the answer that it gives us. Let's see if we are correct. We are! Let's go on to part 2. Okay. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats. They care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat of each in those 8 directions. For example, a seat below would see 8 occupied seats. Okay. Empty seat below would see no occupied seats. Okay. Interesting. Now it takes 5 or more visible occupied seats. Okay. Okay, so we're just changing the rule to, you know, search out in various directions instead of only considering the immediately adjacent seats. So I'm going to copy our part 1 solution. And we will use that to start with part 2. So a whole lot of this is going to be the same, but this count adjacent, we'll maybe change the name of that method to count visible, and this is where things are going to be a little bit different. And also, now it takes 5 or more occupied seats for an occupied seat to become empty. So we'll change that from 4 to 5. And count invisible is what we need to figure out here. Okay, so I'm going to write a little helper function, or a helper method rather, for count visible, which is going to keep on searching in one beam direction until it either hits the edge or it finds an occupied seat. But we'll specify like a horizontal delta and a vertical delta for each step of it, and have it follow that. So let's say bool So these vertical origin and horizontal origin are going to be the starting point of our search, the actual square that we're looking at, and then we will specify a delta for each step, vertical or horizontal, and that will enable us to, just go through the loop, essentially. Sorry for the super long line. I'm just about to format it. There we go. Okay, so actually, I'm going to make these non-const because we'll just change them while we're in here. So we'll say while our vertical and horizontal position is still in bounds, I don't like calling this origin anymore because we're changing it, so I'll just change it to pos for position. You'll say and so while we are in range, if, and we should make sure that we apply those deltas one time before we go into this while loop so that we don't count the original position itself. So we'll say if that is an occupied seat, which is the hash mark, we're going to return true. There is a seat visible in there. We hit one on that beam. Otherwise, we are going to adjust both the vertical and the horizontal position by the delta. And then we'll go around to a next iteration of the loop. Now, if we go through all the iterations of the loop and we don't find anything, then there's nothing visible there because we've run out to the edge of the map and didn't see anything. But the first thing that we're going to do right away before we enter that while loop that has the check in it is just apply the deltas once so that we're not looking at the origin of the origin square of the search itself. Okay, so that is our seat visible thing. So now the count visible is just going to be counting in all of the possible directions from this particular position. So we can just, it's actually just going to be a sum. This is going to be a lot simpler, but it's going to be seat visible for this vertical and horizontal position. And so it's going to be -1, -1 for going up and to the left. And then we'll have plus, and then we're going to have very similar lines across these here. So it's going to be -1, 0 for straight up, -1, +1 for up and to the right, so on and so forth. 0, -1 for going to the left, 0, +1 for going to the right, +1, -1 for down and to the left. You get it. The eight compass directions that we're going through here. And that will be the count. So I think we actually have our solution for part 2 ready to go here. Let's go ahead and put it in the build file. Let's run it on our test input first. Oh, we ran part 1 again, that's why. It still says 37. Okay, part 1 for the test input says that there are 15 occupied after applying the new... Okay. So we've got something wrong here because we should eventually converge at 26 occupied seats, it says. And we converged at 15. So let's look at our program a little bit more here. Make sure we got these rules right. Now it takes 5 or more visible occupied seats for an occupied seat to become empty. Okay, so we still have that. That all looks correct. You know, it's summing these things as bools, and I think that, you know what, that might honestly be the thing that's the problem right now. Because I think if we return these as integers, then it'll actually work correctly. This is kind of a little trick of C++, but I think that basically, like, just the pluses between bools, you know, it's not, you know, actually summing them up in the integer domain, because it's not until that we try and return the result of this expression that it gets converted to an integer. So let's see if that... Okay, no, that is not... That's still not right. Darn, I was hoping I had that. Let's print out the map that it gives us each time and just see how that compares with what we have on the website. So I'll just say void print. Just see what that gives us. Okay. So first time we fill in a bunch of seats. That's correct. So we start with them all empty. they all get filled on the first iteration. This next iteration looks like what they have on the website. I'm just comparing these here. Okay. Now we're starting to see something wrong here. Now something is starting to diverge from what it is on the website. So, oh, we're supposed to consider the first seat, not necessarily the first empty seat. I see. So if the first seat they see as empty, then yeah, I did not read this quite as closely as I should have. Okay, 26, that's the correct answer. So, it just always behooves you to read the puzzle description really closely, I guess, is the moral of this story. So now we can get rid of those debugging statements, and we can run this on our actual puzzle input for day 11. Yeah, if we hit an empty seat, then, it's considered empty in that direction. Okay, answer it gives us is 1986. Let's see if we're correct here. All right, we got it. So that is another day of puzzles in the books. Let's see how we did today. Okay, pretty good on both parts. Low thousands. Pretty happy with that. Yeah, so this puzzle is kind of like a spatial reasoning thing. Not too complicated. I think, as you saw, things that tripped me up. A thing that tripped me up in part 1 was being off by 1 on these things, because, if we're going to be looking at a size, at a coordinate +1, it better be at least, it better be at least this below the size -1, because we're going to, that +1 and that -1 cancel out. And then in part 2, the only thing that tripped me up in part 2 was that I didn't read the puzzle description closely enough, because I was just looking for an occupied seat any distance away. But if you see an empty seat in the line of sight before you see an occupied seat, then that direction counts as empty. So yeah, I mean, like I said, a couple of small bugs here. You got to see me use the debugger a little bit to find out exactly where that seg fault was happening because of my bad bounce checking. But that is a good tool to have in your C++ toolkit. I know a lot of times when something has been going slightly wrong so far in these puzzles, I've just been using, I've been using cout or cair to debug, but it's kind of the moral equivalent of printf debugging. But using an actual debugger can really give you a lot of power, and if you compile with debug symbols, you can see exactly the line on which something fails. You can print out the values of the program while it's running. So yeah, a debugger is a really powerful tool, figuring out crashes like that. So that is going to just about do it for tonight's stream. Thank you to everyone who's tuned into the stream. If you're watching this on YouTube, you can find links to the live streams on Twitch and to my GitHub down in the description. For those of you watching the live stream, you can always catch the replays on YouTube. I will upload these solutions to GitHub later this evening. You can find them on my GitHub. That's github.com/Craig-Chasseur/AOC2020. You can see the repo right there. Thanks again, everyone, for tuning in, and I will see you tomorrow night for another Advent of Code puzzle. Oh, and one more thing, just want to say happy first night of Hanukkah to everyone who's celebrating. And yeah, thanks for joining me tonight. I'll see you tomorrow. Bye-bye, everyone.